Okay, guys, we're going to go ahead and get started. I'll wait for this box to move out of the way. But today we are starting a new unit. It is all about exponents. And so today we're going to be focusing on how we multiply exponents. So we're opened up to page 4 so we can write down our review and test date. So our review is going to be on, let me double check. Okay, it's going to be on Thursday, 2-14, so that is next Thursday. And our test is going to be on the following Tuesday, 2-19. One thing I want to tell you guys while you're writing this down about exponents is we are going to learn quite a few different rules, and so it's important that we master each rule as we learn them, because at the end we're going to have to put all the rules together. All right, so now we are opened up to page 8, where we actually are going to start talking about multiplying exponents. So before I get to some of these properties, I want us to remind ourselves the reason we had the warm-up we had today is because if I had x plus x, that's going to equal 2x. So whenever you're adding variables, we just change the coefficient. We're not changing anything about the x. If I had x squared plus x plus 3x, the only thing that we're allowed to combine there, like we've learned before, is our x terms. So we're going to end up with 4x, x squared plus 4x. Those are completely separate terms, the x squared and the x. I want to refresh your memory of that because today we're going to learn more about how we can change exponents when there's multiplication. So these properties, these are not properties that you have to memorize or know the names of, like with the commutative property and properties like that. You do not have to know these ones by name. You just kind of have to know what they do. So the product property of powers, product of powers property is when if we multiply two terms together that have the same base, we are going to add the exponents. So if you look in the algebra example, the base in both of these is a, so I'm able to add the exponents, m plus n. So we're going to use this example below, m to the 4th power times m to the 5th power. So what we're allowed to do, since both of the bases are m's, is we can do 4 plus 5. So it just equals m to the 9th power. You don't necessarily have to write this step here, but I recommend that you do just for notes purposes, so when you look back, you remember what to do. Next, we have the power of a property, power of a power property. Struggling, guys. So this property says that when we are multiplying exponents, or essentially when we're distributing exponents, you multiply them. So we have these parentheses around a times the a to the m power, but then the n is on the outside. Just like if we had normal distribution, you would distribute your 2 in and you'd multiply. We're going to do that same thing now that we have parentheses again. So I'm going to do a and then m times n. So we're going to practice with the example below. Distributing our 2. This 4 is attached to your y. So it's not two separate things. Y to the 4th is one term. So this 2 is going to the 4. So I end up with y to the 4 times 2. So I end up with y to the 8th as my final answer. Last one, we have power of a product property. And this is saying that if your bases are not the same, they can't be combined, obviously. But if we are multiplying, or if we are distributing an exponent, it's going to be distributed to both of your terms inside. So a gets the power of m and b gets the power of m. So we're going to, in this example, distribute our 3 to both. So I end up with 4 cubed times x cubed. And 4 cubed, we do have to simplify it. Whoa. And we end up with 64 x cubed as our final answer. Okay. We are going to kind of skip around a little bit. So we're going to start with number 1, just because. So we're going to do 1, 2, 3, and 6. All right, so number 1, we have x squared, x cubed, and x to the 5th all being multiplied together. They are all the same base, meaning that we get to add their exponents. So I have x to the 2 plus 3 plus 5. So I have x to the 10th power. In number 2, again, we have y to the negative 3, y to the 7th, and y to the negative 2. Those of you that have learned exponents before, I know there is something different we do with negative exponents, but let's not worry about that right now. We're going to be learning that next class. All we need to do right now is continue what we're working on. So we're going to be adding these together. So I have y to the negative 3 plus 7 minus 2. So I have y to the 2nd. Because negative 3 plus 7 is 4, minus 2 is 2. Number 3, we have brackets and parentheses going on here. So remember that you work your way in. So this 2 is going to be multiplied by this 3. So I now have negative 3 to the 6th power. Remember, it gets multiplied because it's being distributed. And now my 6 gets to go to the negative 3. So I have negative 3 to the 6th. Whoa! I have negative 3 to the 6th power. And the only reason I'm not rewriting it is because there is something I need to explain to you guys. So we're going to pause with number 3. I'm going to blow your minds here for a second. Negative 3 to the 6th power is different than parentheses negative 3 to the 6th power. The reason is in the first example, this 6 is only attached to the 3. So that's like saying 3 to the 6th power with a negative tacked on the front. Whereas in number 5, this 6 is technically being distributed to the negative and the 3, because remember, a negative is the same as a negative 1. So this is basically saying negative 1 times 3. And they both get that power of 6. If you were to type in your calculator the first example, which I actually want everybody to do right now. So if you type in negative 3 to the 6th power without parentheses, and then negative 3 to the 6th power with parentheses, the way you see it written, you're going to get 2 different answers. So go ahead and do that. I want to prove to you why. So everybody should be typing it in their calculator. Okay, so hopefully you realize that this first answer is going to give you a negative answer. The second one's going to give you a positive answer. So let's go ahead and figure out now what 3 times 3 times 3 times 3 is. Should be 729, right? So we end up with 729. Okay, so that's your final answer there. All right, so now in number 5. Number 5, this negative is out front, so we can't do anything with it. It's outside the parentheses. We do, though, need to distribute our 3 to everything inside. So hopefully inside the parentheses, you see 3 different terms. We have 6, we have x to the 4th, and we have y squared. So that 3 is going to, the 3 is going to go to the 6, so I have 6 cubed. And then it's going to go to the x to the 4th power. My exponents get multiplied, so I have x to the 12th. And then it's going to go to y to the 2nd, so I end up with y to the 6th. Simplify what you have here, and the only thing we can actually simplify is that 6 cubed, so I end up with 216 x to the 12th, y to the 6th. But we still have that negative out front. So my final answer, this negative is just going to get tacked on the front. So I end up with negative 216 x to the 12th, y to the 6th. Okay. So now in number 6, hopefully I'm not moving too fast. We can still review when I get back from my meeting today. In number 6, we need to distribute the 4 to the 3 because we have those brackets and parentheses. And we're going to end up with a plus 1 to the 12th. How many of you, raising your hand, and I know I can't see you, but hold yourselves accountable, how many of you want to distribute the 12 to the a and the 1? Okay. So I'm going to tell you guys that we actually can't. We can't distribute the a to the 12 because, or sorry, wow, the 12 to the a and the 1 because we have this plus sign in the middle. That plus sign does not allow for us to multiply the exponent in. If you've paid attention so far, you've noticed that everything we've multiplied in, like up here in our power of a product property, it's all been multiplication inside the parentheses. Whenever you have addition or subtraction inside the parentheses, the problem is solved completely differently. It's called factoring or foiling. And we will be getting to that in a future unit. So for number 6, your answer is actually just a plus 1 to the 12th power. Okay. All right. We are going to do number 7. And then you'll go back and do number 4 by yourself. So number 7, there's a few ways we can solve this. We have a lot going on, but one thing I always like to do is find the terms that are the same. So I see an x to the 4th and I see an x squared. So I'm going to write those next to each other because they're just being multiplied. Remember, 2 parentheses next to each other. They're just being multiplied. So it's okay if I split them up with the parentheses. Then I see y cubed and y to the negative 1. So I'm able to combine the terms that are the same. So my final answer would be x to the 6th, y to the 2nd. Remember, we are adding our exponents because the bases are the same and there's no parentheses distributing the exponents together. Remember also, last thing about this one is that we write our variables in alphabetical order. So x first, then y. Go ahead and do number 4 by yourself. Okay, so when you distributed your 2 in, you should have gotten 4 and w squared. Because the 2 goes to the negative 2 and the 2 goes to the w. Negative 2 times negative 2 is 4. All right. Oh. Okay, so on page number 9, we're going to put everything together. So we're going to come back to this. How do you know what part to solve first? So let's scroll down to number 8, 9, 10, and 11. We are only going to do one of them together, and then you're going to do the rest by yourself. So in number 8, the first thing you always want to do is distribute your exponents. So in number 8, we're going to distribute our 3 to every term inside. So I have the 4, the x squared, and the y. So I end up with 4 cubed, x to the, hopefully we said 6th, because we are multiplying, we're distributing it in. And then I have that times x to the 5 still. So 4 times 4 times 4 is 64. And then I notice that I can go ahead and combine my x to the 6th and my x to the 5th. So that's the next thing you always do, because now we are on the simplifying phase. So I add them together since my bases are the same. So I have x to the 11th and then just y to the 3rd. Remember, I did my x's first because alphabetical order. So coming back up here to how do you know what part to solve first? The first thing we always do first is distribute exponents. Not every problem's going to have this, but if it does, that's what you always do first. Then we are going to simplify numbers. So how I had like my 4 cubed. And then I'm going to combine like bases. So like below I had my x to the 6th and my x to the 5th. So if we want an example for distribute, we can write what we had in that first problem as a reference point. So for multiplying, these are always the 3 steps you're going to follow. As we continue in the unit, we are going to add more steps onto this. Go ahead and pause the video and please complete 9, 10, and 11 by yourself. They are going to be a little challenging, but do your best. Okay, so in number 9, hopefully we got the variables correct, x to the 8th, y to the 16th, z to the 7th. One thing we didn't get a chance to really cover yet, and I apologize for this, is our numbers. So I have a -9 times 5. We are going to treat those numbers just the same as we would any number. It's just -9 times 5. So it ends up being a -45. So when it says above, simplify numbers, that does also include multiplying your numbers together. So a -9 times 5. Okay, so there's number 9. Here's 10 and 11. And if you have questions, you can pause the video now and we can rely on some of our other classmates to maybe help clarify some of those questions, or later when we're working on our worksheet, or when I come back later, we can ask questions then as well. Okay, so we need to also open to page 10 now, and we need to apply these rules to scientific notation. Quick refresher, scientific notation, standard form is your just average number. Scientific notation is when we have times 10 to an exponent. Your first number is always between 1 and 10. So 5.2 is between 1 and 10. Your base, so there's that 5.2. Your base here always has to be a 10 with an exponent that is positive or negative. So as a quick refresher, go ahead and write each of these numbers in scientific notation. This is review from last year. We should be okay doing this, so do 1 through 4. And pause the video now. Okay, so hopefully this is what we got. Just a quick little reminder, whenever you have a number larger than 1, you have a positive exponent, and if you have a number less than 1, you have a negative exponent. Therefore, so like in numbers 3 and 4, I have a positive exponent, that means large number, negative exponent means small number. So now when we apply this to the rules of exponents, the rules stay the same. When your base is the same, you add your exponents. When you have an exponent on the outside, you distribute it in. Remember that these multiplication symbols, even though they look like X's, they are multiplication symbols, and we always use that type of multiplication symbol for scientific notation. So in the first one, we are going to combine our like terms here. So I have 1.4 times 7.6, and I end up with 10.64 times, then I have 10 to the fourth, 10 to the third, same base, so I add the exponents, and I end up with 10 to the seventh. The only issue here is that 10.64 is not in scientific notation, so I need to move my exponent 1 over. So my final answer is 1.064 times 10 to the 8th power, because that's adding an additional step that I would have to do to move it back out. In number 6, my exponent's on the outside, so it needs to be distributed in. So I end up with 1.5 squared times 10 to the, remember we multiply our exponents, so it's 10 to the negative 6. Simplify your 1.5 squared, so 1.5 times 1.5, and we end up with 2.25 times 10 to the negative 6. This 2.25 is in scientific notation, so that is our final answer. I would like for you guys to please do 7, 8, 9, and 10. When you are finished with 7, 8, 9, and 10, there is a worksheet on the scratch paper desk that I would like everybody to complete. There are some challenge problems on that worksheet with geometry problems. And so I will have up on the board the necessary formulas you need to be able to solve those. And you can pause the video, and when everybody's ready, you can resume and the answers will be up.